A river is much more than water. It is home to countless species, a source of livelihood for communities, and essential for environmental balance. However, many bodies of water face an invisible threat: heavy metals. Among them, zinc often goes unnoticed. Although it is essential in small amounts, in excess it becomes toxic, harming aquatic organisms and disrupting the entire food chain. In Mexico, rivers such as the Querétaro River and Turbio River are affected by industrial pollution, where excess zinc exceeds the ecosystem's natural capacity. The problem is that heavy metals persist for years, making it very difficult for water bodies to recover and impacting surrounding communities. This is how EcoLignum was born, a biotechnological solution designed to capture heavy metals present in water. Our system uses bioadsorbent beads made from recovered lignin, immobilized with an alginate matrix. Thanks to their phenolic and carboxylic functional groups, these beads act as active sites capable of attracting and retaining metal ions. In other words, they transform a biologically sourced material into a tool for environmental restoration. To develop our solution, we first extracted lignin from brewer's spent grain using ultrasound-assisted alkaline hydrolysis. The recovered lignin was then incorporated into alginate beads, creating a bioadsorbent designed to remove zinc from contaminated water. Finally, the absorption capacity of the bioadsorbent was evaluated through zinc removal test, and its efficiency was quantified using atomic absorption spectrophotometry. To evaluate the effectiveness of the material, we calculated the zinc removal percentage based on the difference between the initial and final zinc concentrations in the water. The results showed an average removal efficiency of 94.75%, demonstrating a high capacity for capturing zinc ions from contaminated water. These findings indicate that EcoLignum can actively interact with metallic contaminants present in water, significantly reducing heavy metal concentrations and contributing to improved water quality. But useful technology shouldn't stay confined to the laboratory. That's why we developed a modular buoy inspired by Saturn's structure. The central sphere provides buoyancy and stability. The outer ring contains the bioadsorbent beads, allowing water to circulate continuously through the system. This design facilitates monitoring, maintenance, and replacement of the adsorbent material, enabling adaptable deployment in various bodies of water. Each buoy acts as a silent guardian, constantly working to capture contaminants. The EcoLignum story doesn't end when it captures a contaminant. Once saturated, the beads can undergo regeneration processes to recover some of the retained metals and extend the system's lifespan. This allows for waste reduction and progress towards a more sustainable and scalable solution. We envision bodies of water where pollution isn't a permanent sentence, where biotechnology and nature work together to restore ecosystems, where communities can once again trust their water resources. EcoLignum doesn't seek to replace existing treatment systems. It seeks to become an ally in recovering what we've taken for granted for years, because when we protect water, we protect life, and every river deserves a chance to recover.